Okay, so let's take a look at a couple of these. Okay, maybe we'll start off, sounded like there were a couple questions on complex plane stuff. So why don't we look at a couple of those first? And I'm just going to pull questions that are going to be on the review, those kinds of questions. So something like this. And I'm not even sure we'll go through these all the way. You can kind of control that. I don't know that it'll be necessary. Okay, so stuff like this, complex plane stuff. What are we going to do here? You're supposed to simplify this. All these, and I'm not going to give you, really difficult, super difficult, long ones to do on the review or the test, because they just take too much time. But what do we always do with these complex numbers? If we're going to simplify. Yeah, we combine, we're just going to follow order of operations like we normally would. Simplifying numbers. We know simplifying any numbers, real or complex numbers with imaginary parts, doesn't matter. We follow normal top-down PEMDAS, right? So inside parentheses, looks like in here, because I've got some brackets, right? I'll just add up like terms. So that's going to give me what? 4 plus 2 is 6, negative 4i plus negative 2i is negative 6i. And then inside here I've got another set of brackets. Negative 1 plus 5 would just be what? 4 minus 4i minus 2i minus 6i. Right? And then we're just going to FOIL it out, combine like terms, right? So if we FOIL this out, what are we going to get? What's the first term? 24?
36, negative 36.
Minus, because we're doing the odd product of the outer terms, right? Minus 36i. Minus 24i.
No, plus 36i.
Okay, so plus 36i squared.
Which is going to be minus 39.
Right, and the I squared just turns that into a minus, right? That's it. Just combine like terms and we're done. Now, some of these are tougher than others because in some cases you have to divide. But what's our rule for division? Well, what do we do with division? Like, let me pull up maybe just one more of these. Now, we won't go through the whole thing, but like, what about that guy? We're just going to combine like terms on the top, combine like terms on the bottom, and what do we do when we divide complex numbers? Multiply top and bottom by the, not reciprocal, the complex conjugate of the bottom, right? Okay, make sense? So are we okay with those? Okay. And once again, I'm not going to give you as hard of questions on the test. I mean, they'll be more like this and not just tons of powers of these things. Those just take too long to do. Okay. Now, I might put a couple of those on the graphing calculator test, but then you can use your graphing calculator. Everybody knows how to do that. So there, I'm literally, you want me to review that?
Yeah.
So there, I'm literally just testing your ability to let your calculator do it for you. You don't have to even think about it, but I want you to know how to do that. It's a really valuable tool. So let's pull that up. While I'm pulling that up, remember though, you can't use, this is something to remember because people will get screwed up on this. You can't use the fraction template with complex number mode on the graphing calculators. Right. Okay, so right, so for example, if I wanted to solve that on the calculator, all I've got to do is go to mode, go down to the, near the bottom where it says real, A plus BI, and then another option. We want A plus BI as our option, right? And then we're just going to enter this thing and ask it to simplify for us. So because we can't use fraction mode on this, we're gonna have to enter this as one big fraction, right? Now, one thing though, can everybody see that, or does that need to be bigger? Can you see it back there? Okay, so are those parentheses necessary here? They're not, are they? Right? They're because I've got coefficients of +1, I can just get rid of them. They don't do anything. Same thing as distributing a 1. So when I go in here then and I'm entering, say, the top fraction, I don't have to put those individual, those other parentheses in there. I do need parentheses around the whole numerator and the whole denominator, right? So I could just put that in as 2 plus 2, and remember the I is just behind the decimal point, so I go second I, plus -4 would just be -4, right? And then plus 4I, close the top, divide by, open up the denominator, -2 plus 5, and we could probably even just add those in our head, right? I mean, we don't have to enter them all separately, but what if they were a little more difficult than that? Maybe there were some fractions involved or something. Then we might want to just enter them directly and not do any simplifying ourselves, because we're risking making a mistake. So plus 5I plus 5 plus 2I. Close the parentheses, hit enter, and it's going to give us some big ugly number. Now I'm going to, and we can turn it into a fraction though, right? We can go math, convert to fraction. Oh, did you do
Did
that?
this last time, yeah.
It did it to me, but it works for you guys, right? Okay, so I mean, I don't know why, this is just an old version of this, I can't update it for some reason with our operating system, so I'm kind of stuck with this old thing. But you guys would just do that then, you would just hit convert to fraction, it's gonna give you back the complex number with i's in it, the whole bit, right? Yes?
I think when I saw the graphic calculator, it said
Say it again?
like it on the graphic calculator last assignment.
Mm-hmm.
I think it said put it in general form, unless I was looking at their answer.
What do you mean, said put it in general form?
Like it had us do, like it had a graph and then it said put it in general.
Yeah, there's something like that, right. We'll go through, you wanna go through one of those?
Yeah.
Yeah, we'll go through, definitely go through one of those. Okay, so let's get out of there. Okay, so, moving on. Now, I want you to be, well, this is a small enough group that maybe we can skip through some of this stuff. You just, I don't wanna do stuff we don't need to do, but I wanna make sure I hit everything we do need to do. So what about questions like this? So we're supposed to write exact simplified solutions here. So what are we going to do? Okay, yeah, if we're going to solve this quadratic equation, right, if we got a bunch of fractional coefficients, we want to, first of all, we want to clear all those fractions, right? Everybody agree? Okay, we don't want to be trying to combine all these fractions. So the least common denominator is 12. So we'll multiply both sides through. Whoops. by 12. What are we gonna get term by term then? First term gives us, everybody know how to do that? Right, we just reduce first, 12 over 3 is 4 times the numerator. Remember our trick when we're clearing fractions? So 8x plus 20, right? 4 times 5. Minus 1x, so just minus x. Plus 9. Okay, what's next? Move it to one side. Which side? Left side, might as well. The thing is, we're going to move terms anyway. Why are we picking the left side?
So, x squared is not negative.
So right, we want a positive, right? So we move everything to the right. That's going to give us what? I'll start you off. 2x squared
Plus plus 11.
equals 0. So we got it in standard form. Okay, now what?
Use your
What, say it again? Quadratic formula, for sure, right? Unless this, and remember what our strategy is here. We've really only got 3 heavily used options. There are other obscure options that we probably never use. If we get a quadratic equation in standard form, remember the first thing we always look for is there a single x that we could isolate? Because that's probably the easiest, right? Just by reversing order of operations. There is not here though, right? So if there's not, we want to say, first of all, is it easy to factor? No, it's almost never easy to factor if a is not equal to 1. Now, if a equals 1, sometimes we can find magic numbers so quickly that just do that, right? Just solve by factoring. But most of the time, if it's in standard form, it doesn't factor easily, and so we just put it in quadratic formula. Be done with it. Okay, so remind us real quick, somebody, what is, if we start off with a quadratic function in standard form, what does the quadratic formula tell us?
negative
X equals,
plus or minus square root b squared minus 4ac divided by 2.
all divided by 2a, right? So we get both our solutions there. So if we plug that stuff in, what are we going to get for us? If we plug in these values of a, b, and c,
Negative 9, x equals negative 9, plus or minus square root of 9 squared.
okay, so 9 squared.
Yep.
So Brantley, what's that going to be? Help us out here. Fill in the quadratic formula. So what do we got? So 81, whoops. 81. Okay, put those in parentheses, right? So you remember, you want to be able to count the number of negative signs. So 4 times 2 times, okay, all divided by, okay, so what is that? We can just turn that forward. Okay, okay, simplify, right, and we get negative 9 plus or minus the square root of what? So yeah, it's going to be, I only get one negative sign, don't I? Count the number of negatives in the product. There's only one. Odd number of negative signs means negative product. So we get 81 minus 88, 8 times 11. So negative 7. How are we going to write that?
I squared 7.
Yeah. Yeah, so we get square root of 7. We can put the I anywhere we want to, right? In Moodle, it's not going to matter. Divided by, there's both our solutions, exact solutions, right? Okay, make sense? Now, there's a possibility on some of these that you may end up with numbers under the radical that you can reduce a little bit, right? And we always, oh, but we want to write this. I know what you're going to say. Go ahead and say it.
Oh, well, I thought it was negative 10.
Okay, but this is an exact solution one, right? The ones where it wants real solutions, those are the decimal solution ones, and we'll look at one of those. But this is an exact one. Now, it does want us to write this complex number in standard form. It wants us to write it as a plus bi, that form. So what would I do?
Split that fraction.
Yeah, split it up. All we do is split that fraction up, right? So we end up with negative 9/4 plus or minus the square root of 7/4 I, right? Okay, and it's possible that we didn't have to on this example, but sometimes you might have to reduce fractions and or simplify the radical, but you guys are getting really good at that. Right? That's stuff we practiced last semester. You've been doing it ever since, so you're getting really good. I'm not worried about that.
Question of the, does the I, you have to have it there for the A plus BI form?
It can be it can be on top also. Yeah. I've gone through over the last couple days, I've done another like version whatever, 2.0 of all these questions, and so the feedback that you should get on the review should be just a ton more specific, and they're a step improved, I think, from what they were. All right, so moving on. How about something like, okay, here's the new format I told you I was going to build for the discriminant questions, right? So let's just look at one of these. Okay, so what about this? If enter answers that correctly fill in the blanks. So they give us some quadratic equation. Now look at the wording on it. This is much better. A discriminant based upon the above equation, because really the discriminant could have different values depending on how much you simplify the equation. But the discriminant, what is the discriminant? The stuff under the radical. So the discriminant, D, is equal to b squared minus 4ac. It's just the part that sits under the radical. That's the part, remember what discriminant really means. To discriminate means to choose based on, based on values or qualities or something like that, right? You're going to discriminate between the choices that you make. So the discriminant is just choosing what kind of answers we're going to get. That's all it's telling us, right? If the number under the radical, the b squared minus 4ac is positive, how many, what kind of solutions do we get? 2 real solutions. If the discriminant is exactly equal to 0, then in the quadratic formula, the plus or minus square root of b squared minus 4ac, the square root of the discriminant, just goes to 0 anyway, so it's plus or minus 0. Doesn't change the answers, does it? So we get 1 real solution, and if it's negative, we get no real solutions. Instead, we get 2 imaginary solutions, right? Okay, so all we got to do then is just add the stuff to the other side, find the sign of the discriminant. So if I do that, if I turn this into a quadratic equation in standard form, don't I get 4x squared plus 12x plus 9 equals 0. So the discriminant is b squared minus 4ac. You can probably do it in your head. B squared is 144, right? 4 times a times c, that's 4 times 36 is 144, right? So what do I get then? 0. So the discriminant has a value of 0, which means it has how many solutions? 1 real solution. Bingo.
What about for like one of those that has fractions?
Okay, what if it had fractions? If it has fractions, you really have the option then. You could calculate the discriminant based on using the fractions if you want to. Probably easier to put it into, to clear the fractions first. But it's not going to matter because all it wants to know is the sign of the discriminant. That's never going to change. Sign won't change, huh? The value could change based on how you write the quadratic equation, but the sign never will. Okay? All right. Okay, how are we going to do one like this? Julie, how are we going to do one like that? Good. Now, we're not going to, very good. This is not one where the directions say find all real solutions Round your answers, it's cut off, but round your answers to the nearest thousandth. We're only looking for real solutions. The new versions of these problems are going to have everything underlined, so it makes it, you really can't miss it. If no real solutions, enter in. But all we're doing here is just quadratic formula stuff, right? So this is definitely going to be calculator-driven stuff, okay? On the test, I probably won't give you any that are really hard to enter in a calculator because you won't have a graphing calculator on this part of the test. So they'll just be, you'll have access to the Windows calculator or the ones in the lab. But you get my drift, right? Okay? And mostly those will show up on the graphing calculator part of the test anyway. Do we need to go through one of those? No. What's the one issue here that we want to, what are we going to do with this? Before we do anything, we have to do what?
They're all on the right.
You want to go through it? Okay.
Yeah.
No, I think it's probably not a bad, at least, you guys might tell me that's enough, but let's at least start going through it. Okay, like anything else, these are ugly numbers. But like anything else, when we've got a quadratic equation, what do we always have to do first? Yeah, put it in standard form, right, where A is positive. So which side are we going to move everything to then? Right side. So somebody with I'll rely on you to give me decimal numbers here. Now we can't round these, right? These are exact decimals, we're presuming, right? And so we can't round our results. We need to just take it the way they are. So how many x squareds are we going to get on the right side if I add everything to the left side, sorry. If I add everything to the left side.
Wait, we're going to the left side now?
Left side, right?
Oh,
Because
dang it.
oh, I'm sorry. Never mind. I got that backwards. Sorry. Right side. Yeah.
I got 1.089996.
1.0899.
9.
5.
3 nines and a 6.
And 5.
Um,
I think that's
you
5.
got 5 and you got.
Okay.
I know what it is. It's
Okay, so John, what is it?
Well, I got 1.089995.
Yeah, I see.
Okay. X squared. How many x's? 4. And the constant? What is it again?
0.1.
Negative 0.1, right? Okay, so we just have A, B, and C there, don't we? Right, so all we're going to do then, and this is going to be kind of a graphing calculator issue. Let me shrink that just a little bit here. So really, we've just got A, B, and C, right? We're just going to plug all that stuff into the quadratic formula. So this is where you can be efficient with the calculator. So we could use, we could use here, we're not putting in complex numbers, thank you. Not here. We're not putting in complex numbers, so I think we could use fraction mode. I don't even like to, honestly. I think it takes longer to use fraction mode than it does not use fraction mode. So let's just use parentheses. So we're gonna enter this as a quadratic formula expression. So on the top, we gotta open a set of parentheses that encloses the entire numerator. So negative b is what? Negative 4. We'll do the plus version first. Plus square root of 4 squared. That's easy enough. We can just do that. What is it? 16 minus 4 times. A is ugly, but we'll just write it like that. 4 times 1.0899995 times negative 0.1. Negative 0.1. Okay? We good? Scoot out of the square root. We're going to close the numerator, right? And notice that that's the left or the right parentheses is outside the radical, it needs to be. So divide by, and then open a set of parentheses for the bottom. 2 times a, so 2 times, and there is a fancy way you can cut and paste, but I don't think I can do it on here. Times negative, no, sorry, not negative, times 1.0899995. Close the parentheses on the bottom, hit enter, so there's our answer. There's one of them. We're gonna round that anyway, right? So we're gonna round it to 0.025. Then all we have to do to get the other one is what?
Jump back and grab it.
Yeah, good. So jump up, grab the original expression. What's our shortcut for going clear to the left?
Second.
Yep, second left arrow goes all the way to the left, which saves a lot of time. Then just go over a few places, change the plus to a minus, enter. There they are, both of them on the same screen. Okay? Make sense? Okay? All right. Moving on. Okay. Okay, one of these. We've done a lot of these, so I'm not sure. Okay, what about one like this? What's our strategy for solving this?
Minus 12.
Yes, we're going to isolate x, aren't we? Single x, so all we have to do is isolate x. What are the steps in order to get the x by itself? First we subtract 19, then we multiply by 16, then we square root, then we subtract 22, then we divide by 12, right? Make sense? Yay or nay? Thumbs up, thumbs down.
Yeah.
Go through it? Yep.
What is time
That's really from last semester.
Yeah.
It's been a while ago, but that's something, I'm gonna put those back on there. I want you, that's part of the cumulative chapter 5 stuff you really need to know.
Are we having conflict explained on this test?
Just a couple of questions. I mean, nothing complicated. Just, yeah, you have to be able to, I'll show you what they are. Real simple, 3 simple questions. Okay, so let's see, we're gonna subtract 19. 12x plus 22 squared over 16 equals what, -7? Everybody with me? Everybody up here, please. So multiply by 16. What is it? -112. Okay. Square root, right? So let's see. Perfect squares in 112. Got to be 4. So I'm going to get plus or minus. Let's see. 4 would go into that. That would split into 4 times.
16 goes.
What? 16 goes in?
Yeah.
16 times what?
7.
7, okay. So plus or minus 4, radical 7, I. Don't forget the I. Questions on that? Everybody okay with that? Okay, I'm kind of going a little faster because I want to get through everything. Add -22, where's it go?
Front.
Front, then divide by 12, right? So we end up, if I do both those things, x would equal negative 22 plus or minus that, all over 12.
So would you divide?
What's the last step?
You, two goes into all of them, so.
Divide it all by two.
Divide it all by 2. And being as I have to write this, I have to split the terms anyway. It's really easier to do if you just split the terms and then reduce the fractions. So we end up with x equals negative 22 twelfths reduces to what? 11 sixths? Plus or minus square root of 7I over 3. Okay, make sense? That's it.
Could we put I on the outside?
Yep, I can be outside too, it's fine.
Okay.
Probably should be outside, that'd be acceptable also, either way. All right, we're getting there. Okay, one of these guys, yeah. Okay, convert to simplified vertex form.
Could we also do one with the modulus of like?
Yep.
Something.
Yep.
You know,
Yep, you bet.
X plus B.
Yes. If we don't get through everything today, there may be like 5 minutes worth tomorrow. Those easy ones we'll do at the end. But I think we'll get through everything. Okay, so we're supposed to convert this to vertex form. Okay, what's that mean? Yeah, put it in vertex form. Vertex, what is vertex form? Okay, that's, okay. So we got to convert this to y equals a times quantity squared. Okay, so that essentially just means completing the square, doesn't it? We've got to turn this into a form where we've got a perfect square, right? So that's what this translates to for us in terms of an algebra strategy, complete the square. So let's review this. It's been a little while since we did this. What's our strategy for completing the square on a function like this? Remember?
56.
Okay, good. And let's go ahead and write the f of x as a y. It just seems like a minor thing, but it helps a little bit. So rewrite it as a y. We've got to get the x squared plus bx term by itself, right? So there's 2 steps involved. I've got to subtract 56 from both sides to get rid of that, right? So y minus 56 equals 3x squared minus 27x. And what? Divide by 3, right? Because I have to get, remember, for completing the square, I have to get this is the pattern I'm seeking. I want to get x squared plus bx, right? Because then I can add to both sides what quantity? To make it b over 2
Squared.
squared. Good. And that's gonna factor into always the perfect square, x plus b over 2. Yeah, whatever the number is that we're squaring, right, to create the perfect square trinomial, whatever that number is, that's the one that's coupled with x in the perfect square, right? So that's our strategy. We got to divide by 3 then, both sides to get that. Oops. So that gives us y minus 56 over 3. Do I need to simplify that? No, don't, because all I'm going to do is get y by itself eventually anyway, right? Equals on this side, if I divide both terms by 3, I get what?
X squared minus 9x.
Okay, and so what's the magic number I'm going to add to both sides then?
B divided by 2 squared. So negative 9.
B over 2a.
Negative 9 over 2
9/2 squared, right? Which is the same thing as what? If I square a fraction, what do I do?
We square both sides.
Just square both parts, right? So like 81/4. Okay? So that gives us on the right side, what? Okay, make sense? That gives us what perfect square then?
So x plus 81/4.
Oh, x minus 9/2 quantity squared.
Okay, yeah.
That number is what we're adding to x. On the other side, we get kind of a mess, but that's all right. We're just going to undo all those, so you'll simplify, solve for y, or isolate, not simplify. So over here, we just get, we could get a common denominator and stuff, but we don't really want it. It's just more work than it's adding extra work for no reason.
So we minus 81/4.
Yeah, let me get rid of this stuff. Right, so what are the steps in order to get the y by itself?
Minus 81/4.
Minus 81/4,
Multiply by 3.
multiply by 3,
56.
add 56, right? That's it. So y minus 56 over 3 equals this, minus 81/4. Multiply 3 through both sides. Now on the right side, that means distribute. Do I try to distribute inside this quantity? No, I can't anyway, because it's being squared, right? And really all I want is a times the quantity x minus h squared anyway, right? So that's what we need. So we end up with y minus 56 equals 3 times the quantity x minus 9/2 squared plus 2/43.
Should it be minus?
Minus, sorry, you're right. Minus 2/43. Last step, add 56. That's it. So then we get y equals 3 times the quantity x minus 9/2 squared plus 56 minus 2/43. And this is something, all you got to do there is just add up those fractions, right? Okay, make sense?
56 minus 4 and then we'll have a common denominator.
Right, just multiply by 4/4. So what are we gonna, we're gonna get, what is that? 424 minus 443, so 19, minus 19 fourths. So all this would just become minus 19 fourths.
Right? Which would, and so you would just be.
Okay. Yeah, and once again, on the test, on the review, I might give you one like that, but on the test, I'm probably not gonna make it quite that hard, just because they take too long. Okay.
How many questions do the test do?
I don't even know. I don't know. I mean, I might even break it into, it's 2 parts for sure. I might even break it into 3 smaller parts, just so it's, you know what I mean, for your benefit.
Yeah, that's always nice. That way if you.
Oops. It's easier to, yeah. Okay, so with this, if I want to put this into vertex form, now this is the stuff that you've most recently done, so probably it's the freshest in your mind. What are we going to do with this if I want to put this in vertex form?
The vertex is H and K.
Okay, so the vertex is H and K. We can see right here on the graph that the vertex HK has what coordinates? 6, 1. So those are the values of H and K, right? So if we substitute those into vertex form, we get y equals a times x minus 6 squared plus 1. What's the last step to solve for a?
It's 1/2.
Just choose that.
You could put in the other another point, or you could just see that as 4/18.
Okay.
If you want.
Okay, so we got 2 options. We could either just, we have this is the fail-safe method, right? We know that the coordinates at that point are negative, or positive 2, negative 7, right? So I could plug 2 in for x, negative 7 in for y, and solve for a, right?
Right.
Okay, and then I'd have all three values, a, h, and k, and so I just write the function in vertex form.
You
Okay,
don't solve it.
what's that?
You don't solve
It's
it.
really good.
Say it again.
You don't solve it. You just write it.
All it wants is write the quadratic function in vertex form. Yep, that's all it's looking for. And what John was saying is there's a little trick that we know, if you're comfortable with it. If I scoot right or left by a certain amount, in this case, if I scoot left by 1, 2, 3, 4, normally we would expect, if the parabola opens down, if a is 1, we would have to move down by 4 squared, right? 16. But this time we only go down 1, 2, 3, 4, 5, 6, 7, right? And so, boy, that's inconvenient. No, 8, should be 8,
It's
right? It
8.
goes down 8. So we're only going down 8, should go 16, that's half as far as we should go. 8 is negative 1/2. Or 8 is negative 1/2.
So, but what do you do? I have time. I don't have this.
Mhm.
So what do you do for